Yes, guys. So we are back from the interruption with Zoom as usual. So as I was saying, we use these symbols or these letters when we're denoting functions, F, G, H, and phi. So these are the symbols that are used regularly. All right. Now, NB, note briefly that f of x does not mean that you are multiplying f by x. Now it is important that you bear this in mind because we have been using brackets when we are multiplying anything outside by anything inside. But it is important that you know that this does not mean anything of multiplying. This is just a symbol that tells you that we have a function f of x, we have a function g of x, we have a function h of x, we have a function phi of x. So once you see these symbols, we are not multiplying what is outside by what is in the brackets. All right, guys. So it's important to bear that in mind. All right, moving on. So here now, we have our first example. So we are saying now, if f of x is equal to x squared plus 7x minus 5, we are to find the value of f of 2 and f of negative 1. Now, what that really means, if you look at how we define our function, then on the left-hand side of the equation, we have f of x. Now, it means that inside the bracket here is an x value. Now, if you're given f of 2, it means that inside this bracket, you're going to replace the x with 2. Now, if you replace x with 2 on the left-hand side in this bracket, you have to replace the x with 2 on the right-hand side. So you look for the x on the right-hand side and you replace it with 2. So what you're really doing, you're really plugging in the values or the value inside the bracket, both on the left-hand side and on the right-hand side of the equation. Right, so wherever x is, you're substituting this value in the bracket for x. All right, so let us work these two values out. So f of 2 means that you're substituting the x equal to on the right-hand side wherever you have x. So in x squared, you're going to have 2 squared. 7x means that you're going to have 7 times 2. And then you minus 5. So this is what it looks like. So f of 2, so we plug the 2 here, 2 here, 2 here. So on the left-hand side, we put 2 in the bracket where the x would normally be. On the right-hand side, we put 2 where the x would be on the right-hand side. And then now we calculate the values on the right-hand side. So on the right-hand side, if we square 2, we'll get 4. And then we multiply 7 times 2, we get 14. Then minus 5. So all we can do here now, we could go ahead and just quickly add the positive values. And so that will give us positive 18. And then we can now subtract our negative value, which is negative 5. And so we will get the result to be 30. So now we can say f of 2 is equal to 30. All right. So that's how we work out these values, guys. So for the next one, we have f of minus 1. So just as before, wherever we have x, we plug in the negative 1. on the left-hand side. On the right-hand side, wherever we have x, we put in -1. And so we do our calculation. -1 squared gives you +1. And then we have 7 times -1 give you -7. Then we have -5. Now here we have two negative values. We want to add them and keep the negative sign. So we have 1 minus 12. So now we have a +1 and a -12. So you will take away 1 from 12 and keep the sign of the larger number. So this will be -11. Now remember, guys, if you go back to the idea of what you have and what you owe, so you would owe $12, you have $1, you pay back the $1, you're still owing $11. All right, guys? So that's the same principle. All right, any questions so far? Are you following? Raise your hand, guys. All right. So graphs and functions. So as I said before, we have some graph of some special functions. And so we're going to look at those. Now these functions, you just need to become familiar with them. So the reciprocal function would be the function x such that, so this is the reciprocal function. So f of x such that x is mapped onto k over x. Another way you could write this, you could say f of x is equal to k over x. All right. So this way would pretty much easier to be written than the way that we have it here, but they mean the exact same thing. All right. So what the graph of this looks like, you just need to become familiar with what it looks like. So this is the graph of k over x, right? So you should be able to just look at this graph and know that this is a function k over x. And I must bring this to your attention that they can give you these graphs in multiple choice and just ask you what they are. And so you should be able to know what they are just by memorizing these graphs. All right, so this is a graph, which is the reciprocal function graph. And it is one, because remember when we were just looking at coordinate geometry, and I say 2, when you have the negative reciprocal of 2, it would be equal to -1 over 2. All right. So this is called the reciprocal function because whatever x value you get, you put 1 over it. So if x is equal to 1, well, start off with 2. So the reciprocal would be a half. X equal 3, the reciprocal would be 1 over 3, which is a third, and so on. Any question, guys? So this is how it would look if you should plot a range of values for x. You plug in the x value here. You have 1 over x. That will give you the graph of the reciprocal function. All right, now the graph of x cubed. This is also a function, and this is how this graph looks. Now, as I said, you need to just memorize these graphs because they are popular graph when it comes on to function. So as a math person, you're expected to know them. All right, so this is a graph of x cubed. Any question, guys? All right, so Now, here we have y equal x cubed, but denoting a function, we could write f of x is equal to x cubed. All right, so this would be the formal way of saying that this is a function. All right, here now we have a graph of 1 over x squared. And so this is how the graph of 1 over x squared looks. All right, so you just have to become familiar with it, all right? All right, next we talk about the inverse function. Let me go back to the other one so that you can clearly see what is happening, because this diagram color scheme is not so nice. All right, so here you would have, here would be the y-axis. All right, and you notice that this is like a mirror on either side of the y-axis, right? It's a mirror. So this is the graph of 1 over x squared. All right, so inverse function. All right, now, one of the things that we know in mathematics is that we want to be able to find inverse. Now, for functions, and we know a function is an equation. Now, if we have a relationship, which is a function, so we plug in our x values and we get our y values. So it means that for the function f, we would put these x values in the function f. And when we work out the calculation, we will get our y values, all right? Now, if you should have an inverse function to this f function, what do you think we should have in terms of our coordinates? Guys?
Sir, for the first one, we would have 1 over 3.
All right, so, well, we are not looking at, no, we are not looking at reciprocals. Sometimes we use inverse and reciprocal interchangeably, but they don't necessarily mean the same thing all the time. All right. So when we're talking about an inverse function, now we're saying that what would be an equation that we could use now, so that if we plug in our y values, we can get back our x values. So as I was saying, for this function here, right? What we do, we would have plugged in our x values. And we would get out some y values. Now these are just what we consider just some outputs. But suppose now we only have the output. Could we put in these outputs into another function so that we can get back the input, which would be the x values? Now, if we have such function, that function would be called an inverse function. Is that clear, guys? All right, it might not be so clear yet, but we'll be looking at how to find that. So if we interchange our domain and range, we obtain the relation So here now we interchange our domain and range. So now here we flip these around. So we put the 3 over here, we put the 1 over here. All right. So that's what the interchanging is doing. And so on. Now, this function, when we plug in these x values in the function, we get our y values. Now, this is the function f, but here's another function g. If we take these y values, which would be the 3, 6, 4, and 12, 3, 6, 4, and 12, and we plug them into the function g, we get back 1, 2, 3, and 4. And remember, those would give us back the domain that we had in f. So this function then would take the output of f, so whatever the output of f is, so that would be 3, 6, 4, and 12. You plug them in the input where you would have the x in this function, and then now you get back the domain of f. Do you follow clearly what I'm saying? Anybody? I know it sounds a little confusing.
Yes, sir. So far, it's basically a reverse.
Right. So we are saying that if you start off with this function where you put in some x value in it, and you get out these y value, you should have another function where you put in these y value and get back the x values. That's all we are saying. So that function that you can take the y values of the first function and put it in to get back the x values of the first function, that is what we call an inverse function. All right, so now, so these are just the ordered pairs based on f and its inverse g, but we are going to now look at what the inverse functions are like. Now we can say g is the inverse of f, and instead of writing the inverse function as g, we will write it as f raised to the negative 1. So if f is a function, then the inverse of f is written as f to the minus 1. All right, so g here would be f inverse, and f here would be g inverse if you're doing it vice versa. All right, so the definition for inverse function. So f to the minus 1 is an inverse of the relation f and is obtained by interchanging the components of each ordered pair. So what was x become y, and what was y become x. So that's what the inverse function would do. Now let's say that we have this function, and now we want to find the inverse function of f of x. Now we would have to follow these steps. So these are the steps in finding the inverse function of f of x. So we have the function f of x. We want to find f inverse of x. And these are the steps that we will go through to find this function, right? Now, the first step, we write our function f of x is equal to 3x plus 1. We write this in the form as y equal 3x plus 1. So that's the first thing to do. The second step, so the first step we write it in this form, y equal 3x plus 1. The second step, we interchange the x with y. So the x in this, we change it, interchange it. So where the y is, now we put x, and where the x is, now we put y. So that's the second step. We interchange the x and y. All right, so that's our second step. Our third step now is that we make y the subject. So that's the third step. So it means that it was like this. And then now we want to make y the subject by itself alone. And so if we are to do that, then it means that we want to get this one over here. So that would imply that on the left side, we would have x minus 1 equal to 3y. And now, in order to get rid of the 3 beside the y, we divide both sides by 3. And so this cancels leave y. And so we would get y is equal to x minus 1 over 3. All right, so that is what we're doing here. When we transpose, we are making y the subject. All right, now once we have made y the subject, then now we are going to replace this y now with the inverse function symbol. So now we rewrite y equal x minus 1 over 3 as f of x equal x minus 1 over 3. And so now this here becomes the inverse function to this function up here. Is that clear, guys? Any question?
Just ready to get that.
We will do some as practice, but these are the steps that you follow. So it is important that you memorize the steps because you will have to follow these steps. So what you need to remember is what you do first, what you do second, what you do third, and what you do fourth. So let us just walk back through the steps. So we are going to start off with your function that you want to find the inverse of. So you write this function. So instead of using f of x, now you write y. So you replace the f of x with y. So now you have y equals to 3x plus 1. So that's the first step. The second step now, you're now going to switch these around. Wherever x is, you put the y, and wherever y is, you put the x. So that's what we mean when we say interchange. So here we would have then x is equal to 3y plus 1. Following so far? So that would be the second step. Now the third step, we make y the subject. So to make y the subject, we have to solve like when we solve an equation. Bring over the 1 over here. So we would have x minus 1 on the left hand, on the right hand side, we are left with 3y. Now, in order for y to be by itself, we have to get rid of this 3. So we divide this side by 3. Divide this side by 3. This 3 cancels out here. So we have x minus 1 over 3 is equal to y. Now you can flip it around and write it as y equal x minus 1 over 3. And it would be the same thing. So once we have this now, the next step is to replace this y now with the inverse function symbol. So the inverse function symbol would be now f to the minus 1 of x is equal to x minus 1 over 3. And so this is the last part of it. So this now is the inverse function. Is that clear, guys? Is it clear? Any questions? Guys, you need to respond. Raise your hand if you are understanding what is happening. All right, Miss, anybody who is not so clear, let me know. All right, so the steps are pretty much what you need to remember. Once you remember the steps, then it is easy to find the inverse of a function. All right, so here the inverse would be f to the minus 1 of x equal to x minus. Now, one thing to note that this, when you have this fraction, you could write this as 1/3. You put 1 over the 3, 1/3. If you want to write it in a little bit more elegance, you write 1 over 3 and the numerator you put in brackets. And so you would have x minus 1, right? So you can write it like that too. All right. Now here we have a function and we have to find the inverse function of this, and we're doing the same principles. So what we want to do first, all right, well, it asks you to do a number of things. So it wants you to find the value of f of 3. You have to write down the real number, which cannot be in the domain of x. Then you have to find an expression for f of x inverse, and then you have to calculate the value of f of x inverse of 2. All right, what I'm going to ask you to try and do is part A. This part should be pretty straightforward. So do part A, and when you're finished, you let me know by raising your hand. All right, guys, I'll give you about no more than about 2 minutes to work that part out. All right, go ahead, guys.
Sir?
You finished, Mr. Lamar?
So just to clarify, x would be 3, right?
Yeah, man. X would be
So
3.
then, yes, sir.
What you get?
5. So 4 over 5.
So you would plug in the value of 3. So you get
Yes, sir. So
3
would have been
times
9.
3
9.
minus 5.
Which is 4.
Or 3 plus 2.
Which is 5. 4 over 5.
All right, 3 plus 2. All right, so you say that we would have 9 minus 5 up in the numerator.
4.
Over 5.
Yes, sir.
It's 4 over 5. Correct. All right, now I'm not going to do the rest just now. You only have 2 minutes remaining for the class. So this is what I'm going to ask you to do. We'll meet back next tomorrow with this question. So I'm going to ask you to see if you can attempt the remaining questions, are part B, C, and D of this question. And tomorrow we will work it through together. All right, guys? So I'm going to stop here. And then tomorrow we'll continue on this question.